Electrovalent bonds lock different elements together, but what actually acts as the glue? Most individual atoms are inherently unstable, simply because their outermost energy shells are incomplete. Take a highly reactive sodium atom and a volatile chlorine atom. Sodium has exactly one excess electron in its outer shell, while chlorine is missing one. To fix this instability, sodium completely ejects its outer electron. It crosses the empty gap and docks perfectly into chlorine's missing slot, a complete electron transfer. But just moving a tiny particle doesn't explain why these two separate atoms are suddenly glued together. Here's the trick. Losing that negative electron leaves sodium positively charged, and gaining it makes chlorine negative. These massive opposite electrical charges immediately slam the two atoms together. And this violent positive-negative attraction doesn't stop at just one single pair. It cascades outward, locking countless repeating pairs into a rigid, highly structured geometric grid. Think back to that highly reactive sodium and volatile chlorine from the very beginning of this process. Because of that single transferred electron, they are now permanently locked together as perfectly stable, perfectly harmless table salt.
How does a covalent bond connect two atoms when neither side is willing to give up an electron? Non-metal atoms desperately need a full outer shell to become stable, but they will never surrender their own electrons. Take two drifting hydrogen atoms. Each possesses exactly one electron, but they both desperately need two. Since neither atom will transfer its electron to the other, they hit a physical stalemate. They remain completely unstable. So they move close enough to physically overlap their outermost shells, pooling their individual electrons into a shared space. This shared pair now orbits both nuclei simultaneously, tricking both atoms into experiencing a completely full, stable shell. This works for needier atoms too. Take oxygen, which is missing two electrons in its outer ring. So two oxygen atoms share two pairs of electrons at once, forming a strong double covalent bond. And what about those two stubborn hydrogen atoms from the very beginning that absolutely refuse to lose their electrons? They are now permanently locked together by that shared pair, floating freely through space as a perfectly stable molecule of hydrogen gas.